Hello student, my name is Nimish Prabhakar. I am Assistant Professor at LJ Institute of Engineering and Technology in Instrumentation and Control Department. Welcome to Process, Dynamic and Control lecture series. Now start with mathematical modeling. So in this lecture, first we discuss about mathematical modeling. So mathematical modeling. So first of all, question occur in mind, what is mathematical model? So the answer of this question is a mathematical model of a process is a description of the characteristic of a number of phenomena that take place in the process. So this is the definition of mathematical model. So in process we use different equation. We can define one process with different mathematical equation, and by using this equation we made mathematical model. Now to understand this, we take one example, like suppose we have one experimental setup. Now to this experimental setup the input is introduced. If we run the setup, we get some output. Okay. Now my question is, can we represent this experimental setup with mathematical equation? Second time I repeat my question. Can we represent this experimental setup with some mathematical equation? The answer is yes. We can represent this experimental setup with mathematical equation. So this is a mathematical equation. Now if we are giving same input to this block, so we get some output. If these two output are close enough, then we can say that this model is good model. That means if the output first and output second are close enough, that means approximately same, then we can say this is a good model. So this is a nothing but the representation of experimental setup. Now, and this block is known as mathematical model. So in this process, this experimental setup we represent by some mathematical equation. So this is a experimental model. Now one question also occur in mind, what is model? So the answer is, a model is a mathematical representation of a process intended to promote understanding of the real system. So this is the definition of model. So one model of any process is a mathematical representation of a process, and the use of this process are intended to promote the understanding of a real system. So this is a mathematical model. Now next one, the type of mathematical model. So there are different type of mathematical model. So first one type of mathematical model is theoretical model. Second one type is empirical model, and the last one type is semi-empirical model. So mainly model are classified three way. First one is theoretical model, second one is empirical model, and third one is semi-empirical model. Now we start with first one type, theoretical model. So this model is also known as white box model and first principle model. So these are the different name of this model. Like in some books they write the white box model, and in some books they also write the first principle model. Now this model is based on principle of conservation law. We know mainly three conservation law. First one is mass conservation, second one is energy conservation, third one is momentum conservation. Now by using this law like mass conservation, energy conservation, momentum conservation, this model is represented. The model are derived from the physics and chemistry of the process. So this is a theoretical model. Now there are some advantages and disadvantages of this model. So first of all we see the advantages of this model. So first one and the most important advantage is it is applicable for a wide range of conditions. That means we can apply this model on different process. Now second one advantages of this model is it provides physical insight into process behavior. So these two are the advantages of theoretical models. Now disadvantage of this model. So first one disadvantage is it is time consuming to develop because we require lots of calculation to develop a model. So this is really very time consuming. If any process variable is less, then it is no problem. But if number of variable is more, then means 100 or 200 variable, then development of this type of model is really very time consuming. Now second one disadvantage of this is some model parameters are not readily available, like reaction rate coefficient, overall heat transfer coefficient. These are not readily available. So this is the disadvantage of theoretical model. So these are the advantages and disadvantages of theoretical model. Now we see second one type model. This model is empirical model. This model is also known as black box model. This model is obtained by fitting experimental data. Now to understand this, if we have the experimental setup and we have different set of input and output data, that means if at the time t is equals to 0 input is x0, and at time t is equals to 0 output is y0, at time t1 is equals to input is x1, same as we get output y1, x2 we get output y2. So this is the sets of input and output data for this experimental setup. Now so by fitting those experimental data we can determine the coefficient. By that way we can construct a model, and that model is the empirical model. So this is the definition of empirical model. Now we see the advantages of empirical model. So first one advantages is it is easy to develop and usually quite simple. As compared with the theoretical model, it is really very easy to develop and it is very simple because we do not require lots of calculation that required in the theoretical model. So this is the first one advantage of this model. Now second one advantage disadvantages of this model is it requires well designed and accurate experimental data. This is the disadvantage of this model. The behavior predicted by empirical model is correct only around the experimental condition. So extrapolation is usually invalid. So this is also one disadvantage of empirical model. And third one is it is applicable for a limited range of condition. So these are the disadvantages of empirical models. Now third one type of model is semi-empirical model. This model is also known as gray box model because it is a combination of theoretical model and empirical model. So we know the theoretical model is also known as white box model and empirical model is also known as black box model. So combination of white and black, so we get gray color. So this name is the name of this model is gray box model. This model is combined approach of theoretical as well as empirical model as we discussed. Model equations are derived from basic conservation law and certain model parameters. Now we understand by example like reaction rate and heat transfer coefficient evaluate from physical experiment or from process operating data. So this is the semi-empirical model. This model is combination of empirical model plus theoretical model. So basically there are three types of model. First one is the theoretical model, second one is the empirical model, and third one is the semi-empirical model. Now question occur in mind, what are the use of this model or what is the use of mathematical modeling? So first one use of mathematical model is to improve understanding of the process. That means process model can be analyzed or used to investigate the process behavior without the expense and unexpected hazards of operation of a real process. So this is the first one use of mathematical modeling. Now second one use is to optimize process design and operating condition. That means steady state model of process can be used to determine the most profitable operating condition. So this is the second one use of this model. Then third one use is to design a control strategy for the process. Alternative control state gives the model based and model predictive control can be evaluated to select the best process model. So this is the third one, and next one is the fourth one. Use is to train operating personnel. That means plant operator can be trained to operate a complex process and deal with emergency situation by working on process simulator. Like we can understand by example, flight simulator are used to train pilot before they board a real plane. So these are the use of mathematical models. Stability. So first of all, question occur in mind, what is stability? Also, why we require stability, and what is the stability of system, or what is the stability of any process? So now we understand by using by this lecture. So first of all, stability. A system is defined as stable if the control variable converge to a steady state after the disturbance. Otherwise, the system is unstable. So this is a simple definition of stability. Any system is called stable if that system control variable converges to a steady state after some disturbance. If that system that variable not go to the steady state, then this system is called unstable system. Now to understand this, let us one example and see in this graph. In this graph, consider the behavior of variable x shown in figure. Notice that at time t is equals to t0, the constant variable is changed. Like is the time t is equals to t0, the value of x disturbed by some external factor. But that as time progress, the value of x return to its initial value and stay there. That means at t is equals to 0, the value is changed, but after some time this value is steady. So this type of system is known as steady system. Now if we consider this x is a process variable such as temperature, pressure, concentration or flow rate, we say that the process is stable or self-regulatory and need no external intervention for its stabilization. So it is clear that no control mechanism is needed to force x to return its initial value. So this is a simple stability system. Now to understand more, we take another example, like other system is represented by this graph y. In contrast to the behavior described above, the value y the variable y is so in this figure. Figure does not return the variable value not return to its initial value after it disturbed by external influences. See here, the value is not returned to its state after some disturbance at t is equals to 0. Process whose variable follow the pattern indicated by y in this figure is called unstable process and require external control for the stabilization of their behavior. So this is a stable, the left hand side graph is represent the stable system and right hand side graph is represent the unstable system. Here we see the after some deviation the value is come in a steady state, but here after some deviation value is not come in a steady state. So because of this reason, so this is a unstable region. system and this is a stable system. Here x and y is represent the variable, that means anyone, temperature, pressure, anything. Now to understand more stability, by using a transfer function we can also define the stability of the system, like if closed loop poles are located in left hand, then system is known as stable system. That means we understand by using one example. See here, the one system transfer function is given by C of s upon R of s is equals to 10 upon s plus 2 into s plus 4. Now we can find out the pole of this system. We know the pole of this system is the s is equals to minus 2 and s is equals to minus 4. So these two poles and the representation of these two poles in the left hand side, we know this is the real axis and this is a representation of this both poles, we know. So by definition, if closed loop poles are located in left hand, then system is stable. That means this system is known as stable system. And this is a first one minus 2 and this is a minus 4. So this is a representation of this pole. Okay. Now for better understanding, we see the graphical representation of this system. So by solving this equation, we know this system is very exponentially. So at the initial state, the value is deviation, that means oscillate this system. But after some time, this system is tried to stable. So this is a steady state. So this is the behavior of this system and graphical representation of this system. So this is a stable system. Now to understand more, we see second one example of unstable system. See here, so one here given the one transfer function C of s upon R of s is equal to 10 s minus 2 s minus 4. So we can calculate the pole of this system. So here pole is the s is equals to 2 and s is equals to 4. Now the graphical representation of these two poles is in the right hand side. That means here for understanding I take only one pole. So here the representation of these two poles is on the right hand side. So by definition we cannot say this system is stable, because by definition the pole must be represented here left hand side. So this is a not stable system. And the graphical representation of this system is like this. So this is an exponential function but in increasing order, exponential function. And the behavior of this system is like at the initial it start on oscillation, the change, but that cannot return to its steady state value. So we can say this system is unstable because its variable variation is not come in a steady state. So this is a unstable system. Now by using this table we understand more about the stability of the system. So as the nature here the real nature of the closed loop pole, like a real, negative in left hand of the S plot, that means in the left hand side of this side. So that figure is called the stable, or in other words absolutely stable system. And this is a transfer function representation of that system. So this is a transfer function representation and this is a stable system if left hand side is pole is present. Now understand more, we take here the imaginary pole is given like 1 plus 2j, 1 minus 2j, but here both pole is present left hand side. So this is also known as absolutely stable system, because both pole, like here the real pole, but here imaginary pole, but these two pole are in the left hand side. So this is a stable system, and this is a transfer function representation. See here, so initially it oscillate, but it try to steady state. It achieves steady state. So this is a stable system. And if system is not stable, then we require controller, and by using that controller we can stable the system. And here third one is the unstable system. See, the real pole is in the right hand side of the product. So this is because as per definition must be in the left hand side, but here the pole is on the right hand side. So this is a unstable, and this is a transfer function behavior of this system. And this is a complex pole of this system. Here they see the complex pole is also present on the right hand side. So as we discussed about the definition, so this system is also unstable system. So by using transfer function we can also find out the stability of the system. Okay.